HL, hypotenuse leg. Now, word hypotenuse tells us a little bit about why HL is so different than all the other ones, right? We had sides and angles, A and S, S and A, whatever. HL, hypotenuse leg, is different. It only works on right triangles. HL is only used for right triangles. So we talked about having to prove three things, or show three things to be congruent. In this case, one of the things you have to show isn't necessarily congruent, but that you are working with right triangles. Okay, here's kind of how it works. Let's go through an example real quick. In this proof, we have some triangles we're going to prove congruent, like always. KM is perpendicular to JL. Love it. JM is congruent to LM. And we are supposed to show that JKM is congruent to LKM. JKM. That is going to be congruent to LKM. That's the goal. We're going to try and use HL to make it happen. Process is still the same. Let's start with the givens. KM perpendicular to JL. JM congruent to LM. It's given. It's given to us. And in fact, one of the things that's given is something we can mark off right away. JM and LM are congruent. They are the hypotenuses of our two triangles. How do we know that? Well, it's because of the right angle in the picture. Right? Because of the right angle in the picture. Where does that right angle come from? Well, it comes from the other given. We got to go back to the given and make sure we suck everything out of it that we can. Because they're perpendicular, angle JKM and angle LKM are right angles. Why? Well, perpendicular lines intersect in right angles. That's what perpendicular lines do. It's the definition of what makes two lines perpendicular. So for HL, we have now shown part of what we need. We have to show right triangles. We've shown right angles. We're good to go. We can even mark it. There's one, there's the other. Just like we marked congruent before, let's mark that right triangle. Now we have to talk about the leg. How do we prove the leg's congruent? If we had that it was perpendicular and the bisector, we could talk about those JK and LK being congruent. We were not given that. We have used everything we have been given. Once you've used up the given and you still don't have enough, it's time to look to the picture. What does this picture tell us? Well, we can easily see that we have an overlap. KM happens in both triangles, which means if it occurs in both, it's congruent in both. KM is congruent to KM. Why? Oh, the reflexive property. We can use the reflexive property when we have that overlap, because reflexive means that it's congruent to itself. It's the same in both triangles. Let's look at what we have here. Right. We needed right triangles. We needed the hypotenuse. How do we know it's the hypotenuse? Well, look, it's across from the beautiful right angles that we have. And then we needed a leg. Because we've shown hypotenuse, right triangle, and leg, because of all that, we are ready to say, yeah, our two triangles are congruent. JKM is congruent to triangle LKM. Why? Just like before, we had HL. Our reason is kind of what we've been talking about. Quick recap. First thing we were told was hypotenuse. We knew we had to show the hypotenuse. We found a leg. The hypotenuse and leg were not good enough until we mentioned that we had right triangles. We had right angles in our triangle. All three of those things done, that's what allows us to use HL. H and L are taken care of, and that word right is taken care of. That's how we can say our triangles are congruent, and that is the final method, the final your method for talking about congruent triangles.